Hello again. Today we're going to do some sort of advanced factoring. Two types. The first one, I'm going to factor 4-term polynomials. Using an older method, using difference of squares. Okay, so you're going to see 4 terms, but I'm not going to take GCFs out. I'm going to use difference of squares. So here's the first example. Okay, so we got our 4 terms, and you'll notice there are also 2 different variables in this polynomial, x and y. So in Algebra 1, when you see 4 terms, one of the methods we do is take the GCF out of the first 2 terms, and then we take the GCF out of the third and fourth terms. In this case, we can take a GCF out of the first 2 terms. The GCF is x. But the third and fourth terms don't have a GCF, so that method isn't going to work. So instead of looking at 2 groups of 2 terms, I'm going to look at these 3 terms as one entity, because that's a perfect square trinomial right there. So I can factor that trinomial like so, and I won't do anything with the minus x squared just yet. I just want you to see that after factoring that trinomial, I have a difference of squares, and it's in the form a squared minus b squared. That's how I know it's a difference of squares. But in this case, the a is actually x plus 5. And since we know that a squared minus b squared factors like that, I'm going to apply that pattern to the x plus 5 and the y. So this is a plus b times a minus b. And now that is fully factored. Okay, let's do a second example with the same technique, with a little twist to it. Okay, again, I have 4 terms. I have 2 variables involved. I can't do GCF for the first 2 terms, so I'm going to look at a trinomial that is factorable. Look at these 3 terms like I did in the other example. You'll notice that is actually not a trinomial, a perfect square trinomial that can be factored. But if you look at the second, third, and fourth terms, they look like it could be a perfect square trinomial. The problem is the signs are off, but I can rectify that. I can take out a -1, and what's left behind is a perfect square trinomial. So that's the little twist I was talking about. It takes a trained eye to see that if you take a -1 out of the second, third, and fourth terms, what's left behind is a perfect square trinomial. But hopefully you're able to see that this is pretty close. It's just that the signs are off. So that tells you maybe if I take out a -1, what's left over is something good, something I can work with. Okay, so then from there, I can factor the perfect square trinomial. I have a perfect square here, I have a perfect square here, and 49. So again, I can factor the difference of squares. a is 7, so 7 plus b is x minus 6y, and the second factor is 7 minus x minus 6y. And if you feel like it, you can distribute this minus so that you don't have parentheses inside parentheses. So I'll go ahead and do that. Okay. Now, the second situation is called factoring by completing the square. Okay, completing the square is an older method that we use to solve a quadratic. We're going to use completing the square to factor a degree 4 polynomial. So this is a trinomial, but it's not quadratic. It is degree 4. You can see right there, degree 4. And we're going to use our completing the square technique to factor it. Okay, if you look at the trinomial the way it is, you'll see that the first and the third terms are perfect squares. So that makes me think, maybe this is a perfect square trinomial, so I look at the middle term. Well, I'm disappointed, because it's not. Because that 4, the coefficient of x squared, is the wrong coefficient. It would be factorable if it said 8x squared. This would be a perfect square trinomial. So I'm lacking that correct middle term. But I have the power to make it 8x squared, as long as I compensate by taking away 4x squared. This is the completing the square step. I needed that 4x squared to be 8x squared, so I added 4x squared to it and subtracted 4x squared from the polynomial to make it legal, because all I really did was add 0. But by doing so, I accomplished the completing the square right there. So now I can factor those 3 terms. Like so. And I have my minus 4x squared here. And now it looks like those previous 2 examples I did with the 4 terms. This is a difference of squares. So that's a. B is 2x. Here's a again, minus 2x. And it's factored. Okay, I'm going to do one more example of that. It's slightly different in nature. Okay, so again, I see a perfect square here, I see a perfect square here. I think this is a perfect square trinomial, so I look on the middle term. It's the wrong coefficient because I need that to be a 10. I need it to be a 10. But it's a 1. So all I have to do is add 9x squared to make it 10. But to compensate, I have to subtract 9x squared as well. And now I can factor this trinomial. And now I can factor the difference of squares. And then we're done. Okay, so factoring four-term polynomials using difference of, sorry, wrong paper. Factoring four-term polynomials using difference of squares. Look for the three terms that make the perfect square trinomial, factor it, and then you'll have a difference of squares. And then in the second example, if it looks close to a difference of squares, maybe try factoring out a -1. Maybe you'll get lucky and the leftover is a perfect square trinomial. And then with the degree 4s, if the first and third terms are perfect squares and the middle one is not the right coefficient, add something to make it the right coefficient, and then compensate by subtracting what you added, and it might work out. Okay? Thanks for visiting K109 Math, and we'll see you later.